All right, we got 2 lessons today, correct? All right, here's the reason for it. So right now, because of our snow day, our test is scheduled for Friday. That is if we come to school tomorrow and if we come on Thursday. If we do not have school tomorrow, that means the test gets pushed back to Monday. If we miss tomorrow and Thursday, that means the test gets pushed back to Tuesday. All right, we're all in the trolley with the test when it's going to be. So it always gets, every day we miss, it gets pushed back that many days. Your homework. Your homework tonight is to finish lesson 8.6. So it's the one we're going to do the lesson today, and you're going to do homework like normal. That is due tomorrow. That is 100% due tomorrow. It should be done tomorrow whether we have school or not. If we do not have school tomorrow, you have a small addition to your homework. You have to go online and watch the video for lesson 8.7. So that is if we have a snow day tomorrow, you have to watch lesson 8.7 and take the notes on it. You do not need to do the homework. You can start it if you want to get a jump start on it. It's mostly just application problems, so it takes a lot of thinking. And then the day we come back will be a work day on 8.7. So you'll come in, I'll answer any questions people have, and then we're just going to get started working on the homework. All right? And that's when we come back. So it might be on Friday we have that work day. If we have Wednesday and Thursday off, then Friday might be work day. And I'm saying that to you right now because I will not be here on Friday. On Thursday I will be, on Friday I will not. I'm going to the Latin convention. So that means if we don't have school tomorrow or Thursday, we will not see each other. But you will already know what you're doing on Friday because there will be a work day to finish 8.7. Then we'd have a review day on Monday and a test on Tuesday because we would have missed 2 days. All right?
Wait, so we're
yes.
going to have a test on Tuesday?
If we miss tomorrow and Thursday. Because that means we have to push the test 2 days. Okay?
Yeah.
If we only miss 1 day, you're going to see me on Thursday so we can go over all this stuff. Worst case scenario, miss 2 days. Friday would be a work day on 8.7. You would have already watched the video because you're going to watch it tomorrow if we don't have school anyway. And that whole day will be a work day, and then Monday would be a review day. That is worst case scenario. Other scenario is we miss just tomorrow. You still watch the video, work day on Thursday, review on Friday, test on Monday. If we have all of those days, nothing changes, just your regular homework's due tomorrow. Is there any questions of what I expect of you? So one more time. If we have school tomorrow, what am I going to check to make sure it's done? The normal homework, 8.6. What do you do if tomorrow we have a snow day or a cold day? Watch the video and do the lesson. The day back will be a work day. All right, now that we got that all squared away of sorts, it's also on Google Classroom. I say the same stuff on there. Let's go ahead and work our way through this bell work. So this bell work says I'm supposed to find 2 angles. Well, anytime I'm looking to find an angle, I'm always going to use an inverse. I'm always going to use an inverse. And the one we know right now is tangent. So if I'm looking for angle L, I have to use tan inverse. Well, tan inverse of the opposite over adjacent spits out our angle. So we're going to have tan inverse of the opposite of angle L, which is 13, over 84. And that's going to be angle L is about, I forgot what I rounded this to. I rounded to the nearest degree. It didn't tell me what to do, so I just picked degree. And angle L should be about 9 degrees, or 8.8 degrees, I believe, if you round it to the nearest tenth. All right, as soon as we got that ball rolling, the next one should be pretty easy because I just need to find angle J. Well, angle J is also looking for an angle, so I'm going to use an inverse. So I'll use tan inverse. This time our opposite is 84. Our adjacent is 13. And we should get out angle J is about 81 degrees. Do all those numbers look right? Because we should have all done this. Or 81.2, correct. Sorry. All right, since these all look right. Let's quickly go over homework questions. Questions on the homework. Questions on the homework. Yes. Going through 22, yes. So on 22, we'll show a picture and I'll talk about why I did what I did and when I did what I did. All right, it says, so a rhombus has diagonals length 4 and 10. Find the angles of the rhombus to the nearest degree. So if we have an angle 4, let me mark it down below. That means the entire length is 4, but I can separate that then into a 2 and 2. The other diagonal is 10. So that means I could separate that into a 5 and 5. Well, each of these is going to be a small right triangle where I have side lengths 2 and 5. Well, what they're asking for is the entire angle here. Well, I can find half that angle. Do you see this y degree thing here? So I'm going to find this missing angle here, which I put as y equals tan inverse of opposite over adjacent. So that's tan inverse of 5 over 2, which turned out to be 68 degrees. But note, 68 degrees is just this section here. I need to add another 68 degrees to it. So this entire angle right here is actually 140 or 136 degrees. Because that would be 68 plus 1, plus 68 plus 68 equals 136. And then you could find the other angle up here, but you can also just say, well, consecutive angles of a rhombus equal 180. So I just needed to do 180 minus 136. The other one had to be 44 degrees. Do all those steps make sense? A lot clearer? All right. Other questions real quick? Yeah.
For number 24, how do we
For number 24, how do we know what?
the altitude of that triangle on the right?
Oh, because it's half the rectangle. So if we look at our drawing, this total distance is 80. Well, this point is smack dab in the middle. So if I would extend this line like this, see this full line here, this has to be 80. So both halves have to be 40.
Okay. How do we know it's in the middle? Is that like a rule?
Yes, it's a rule of parallelograms that diagonals bisect each other. And for a rectangle, that means these are all isosceles triangles, so it has to be smack dab in the middle.
Okay.
It has to be in the middle because they do bisect each other. The lengths bisect each other.
Yeah, the diagonal lengths bisect
Mhm.
each other. Good.
So if this is equal to this, and this is equal to that, because they're all the same in a rectangle, that means all these are isosceles triangle, which means all of these are the exact same shapes. So if I draw a line here, that would mean that these have to be congruent to each other. They have to be.
Because they're the same triangle.
They're the same triangle. They're the same exact triangle. All right, other questions? All right, today isn't too far out of the box because we covered all of this information. The only thing we're going to do, we talked about tangent for 2 lessons now. Although it took us a while to get through those 2 lessons since we had a lot of snow days in there. But we talked about tangent. Now we're going to add to your plate. We're going to add sine and cosine. But sine and cosine are almost identical to tangent. Everything we do will be the exact same. When I did tangent of an angle equals a side over side, we're now going to be able to do sine of an angle equals a side over side. We'll do the same thing with cosine. So cosine, sine, and tangent are almost identical. The only difference is what side you're talking about. Really quick, sine is abbreviated SIN, cosine is abbreviated COS, and we already did tangent as TAN. If you look down here, this isn't new. Tangent of an angle equals opposite over adjacent. We used it for 2 lessons. Let's talk about sine. Sine of an angle equals the opposite over the hypotenuse. So now we're looking for the side opposite and the hypotenuse. Cosine is adjacent over hypotenuse, but what we did with tangent, we're going to do with sine and cosine. You're going to see it's very identical. You just have to locate what sides you can work with, and then I'll tell you whether you're using sine, cosine, or tangent. Now, real quick, the thing that's going to save your life on this test is something called SOHCAHTOA. SOHCAHTOA. And we're all going to say it together on 3. 1, 2, 3. SOHCAHTOA. Now we're going to say it quietly on 3. 1, 2, 3. SOHCAHTOA. Now we're going to say it louder on 3. 1, 2, 3. SOHCAHTOA. Now we're going to chant it. SOHCAHTOA, 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 SOHCAHTOA. All right, you need to know that. The very first thing I'm going to do on a test, when I get a test, is I'm going to write SOHCAHTOA on the top. That tells you exactly the ratios that we're talking about. So let's talk about what SOHCAHTOA means. So, we're going to start with so. That stands for sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And finally, tangent is opposite over adjacent. If you don't know SOHCAHTOA, you're going to get so many problems wrong on the test because you have to have those ratios correct. So you have to know SOHCAHTOA. You have to know it this year, next year, and in pre-calculus. So this is something that's just going to stay with you. SOHCAHTOA. Let's use it. All right, these are just ratios. We're not actually solving for something. It says sine of A equals what ratio? Well, anytime we deal with sine, so in that first box, I'm going to write sine of an angle. Whenever you're talking about sine, you should think of SOHCAHTOA. And I'm going to go with so. Yeah?
Is SOHCAHTOA an actual word?
No, it's a what's it called? Not an acronym. Yeah, it's an acronym.
Oh, okay.
All right, so sine of A is going to equal, sine is so, which sine is opposite over hypotenuse. So it's going to be opposite over hypotenuse. It pretty much is a word in math. That's what made me think about it, because we say it so much in math, and we just use it. Because I'll say, like, use SOHCAHTOA. And you don't think of it as an acronym. We actually use it in words. Like, it's in books as words. So I could see, like, it pretty much is a word in math. That's what made me pause, because we use it like a word.
More like a strategy.
What was that?
It's like a strategy.
It's a strategy to remember it, but we use it so fluidly that every math book has SOHCAHTOA just written in it, and we'll just say SOHCAHTOA as it is a word. So that's what made me pause. And I'm just like, it is an acronym, but we really do use it as a word. We will use SOHCAHTOA to solve this. You know, we don't say use the acronym SOHCAHTOA. We say use SOHCAHTOA. So it pretty much is a math word. All right, well, opposite over hypotenuse in this case would be sine A equals opposite of A. Side opposite A is that length 5. The hypotenuse of this triangle would be 13. So sine of A equals 5 over 13. We'll do the same thing with cosine. Well, cosine of A, so ka, that hard ka means it's adjacent over hypotenuse. So adjacent over hypotenuse. And we're going to have cosine of A equals that adjacent side. The adjacent side is always the side that's touching your angle. So angle A is here, so it must be 12. And it's going to be 12 over our hypotenuse, which is 13. The good thing about sine and cosine, they're both over your hypotenuse. So if you forget SOHCAHTOA, at least you should know sine and cosine are both over your hypotenuse. Finally, tangent, we're not going to spend a ton of time on because we already spent 2 days on it. Tangent of an angle A is going to be opposite, which is 5, over adjacent, which is 12. All right, let's get our calculators out and actually solve some of these problems. So our first one, they give us a triangle, they give us an angle, and they give us 2 sides. You have to, on your own, the test will not say this section is your sine section, this section is your cosine section, this section is your tangent section. It will not. It will just give you a whole bunch of triangles and you need to solve it. So we look at the fact that they give me 25 degrees. So they give me 25 degrees. What is side x in reference to angle 25 degrees? Yeah, it is our opposite. So you need to, in your head, think either head or write down that this is my opposite side. And if that's my opposite side, that must mean that 18 is my adjacent side. So here's where you need to use SOHCAHTOA. Which one of our three trig functions, sine, cosine, or tangent, uses opposite and adjacent in it alone? Ishana. Tangent. Because they give us adjacent and tangent, we should think tangent of an angle equals opposite over adjacent. And that came from our TOA, if you're using your SOHCAHTOA. Well, we know our A value, so we'll go tangent of 25 degrees equals our opposite, which is x. Our adjacent is 18. We'd multiply both sides by 18 to give us 18 times tangent of 25 degrees is going to equal x. Now let's look at the directions really quick. The directions say to put it to the nearest hundredth. So I need this rounded to the nearest hundredth. So we're going to type in our calculator 18 times. Does anyone dispute that? We're okay with 8.39? All right, cool. All right, our next one. Our next one is, they gave us 38 degrees. So this is what we're going to think in our head. Well, x is that opposite side. Hypotenuse is pretty easy to point out. So now I have opposite and hypotenuse. Which one of my trig is opposite over hypotenuse? So sine of an angle equals opposite over hypotenuse. Other words, so sine is opposite over hypotenuse. So sine of the angle that was given, 38 degrees, is going to equal opposite. We said was x. Hypotenuse is 20 square root of 2. I'd multiply both sides by x, and I'd come up with x equals 20 square root of 2 times sine of 38 degrees. I do want everyone in here to punch this in your calculator. Don't wait for someone else to answer. And the reason why I'm telling you that, if you have a calculator where you have to use parentheses, so a lot of your calculators, when you type in square root, it'll have an open parenthesis. Make sure you put a closed parenthesis going the other way right after you type in that 2. Otherwise, it's going to take the square root of the whole thing. That doesn't affect everyone. Some of you have calculators that just it puts it underneath the square root. So I want everyone to plug that in. And make sure you get out 17.41. If you do not get 17.41, call me over so we can put it in correctly. Because you do not want to get to a test and get a problem wrong because you can't put it in a calculator. Yeah. As you type it in. So you did not put that close after. Yeah, because right now it's doing the square root of 2 times that sine. Yep, there you have, yep, and then you should do the right thing. There you go. Cassie, yours isn't working. Oh, that's why. Use your tangent button. We want to use our sine button. So we do have to use our sine button. Yeah. Oh, see how it's all underneath that square root symbol? We don't want that. So yeah, we'll go over how to do that. So I'm going to hit 20, and I'm going to hit square root of 2. And generally speaking, no, sorry, we can push. You push that button, see how it ended it there? Yep. Other people having trouble?
Wait, 8.
Did we ever put it in degree mode? I don't know if you were here for that. So hit that mode button, let you do it. And do you see how it says radian? We want to go down to radian, push right.
Oh,
Yep, and hit enter now. And now it'll be degree mode. Now we can just either hit clear or, now just hit enter again.
okay.
Just hit enter.
Oh,
There you go. All right. Then I'm going to assume everyone else can use your speak up if you can't use your calculator properly. Now's the time to get it before you get to the test. And you're like, oh, Mr. Baby, no, these are wrong. All right, our last one. We have x. Well, 11 is our adjacent side, because it's definitely not across. 16 is our hypotenuse. Which one do I use for adjacent and hypotenuse? Process of elimination, too. Grant.
Cosine.
Cosine. Well, here's something, a little wrinkle. We have cosine of an angle equals adjacent over hypotenuse. Let's use what we knew about tangent. Everyone look up here real quick. Everyone. Everyone. All right. How do I get rid of that cosine in front of that x? I want x by itself so I can plug it in my calculator. We haven't done this yet, but it's very similar. Sam.
divide both sides by cosine.
You don't divide both sides. Grant.
Inverse cosine.
You do the inverse of cosine. So it's not dividing. It's just like, say I have x squared. You don't divide by square root to get rid of it. You take the square root of both sides, right? So it's the same idea that, and it is, you have to write it this way, that you're taking the cosine inverse of both sides. Because then your cosine inverse and your cosine cancel out. And that's going to equal cosine inverse of 11 over 16. Which will leave us with x equals the cosine inverse of 11 over 16, which when you plug in your calculator and you round to the nearest hundredth, you should come up with 46.57 degrees. See, I'm really glad you said that, because a lot of people do see it as division and they divide stuff out and they end up messing it up. Make sure you recognize that you are doing the cosine inverse of both sides. That's the action that cancels it out. All right, but that leads us to our next big idea, and that is inverses of trig ratios. Our inverses of trig ratios work just like tangent. Remember when I took tangent of an angle and it spit out our two sides? And then we did a tan inverse of both those sides, spit out an angle. It's going to work for all of our trig functions. So in other words, a sine of an angle equals our opposite over hypotenuse. Well, the other direction is sine inverse of your opposite over hypotenuse spits out an angle. I'm going to say this once again. If you're looking for the angle of something, you better be using one of these three inverses at some point. If you're looking for a side, like your side is missing, then you'll just use sine, cosine, or tan. So these are used for a missing side. These are used for a missing angle. It's important for you to recognize it because you will make mistakes. You'll forget to use inverses. But if you get a degree measure out and you never use an inverse, you probably don't have the right degree measure. All right? So this is to find an angle. This is to find a missing side. And before we get to that, we're going to highlight real quick what we just did, what Sam taught us how to do, or told us how to do. Whenever I have sine A equals 0.87, I can't plug that in my calculator. Because most of yours don't even have an A button on it, let alone. So you need to get A by itself. To get A by itself, you just take the inverse of the trig function they gave you. So if they give you sine, you're going to use sine inverse of both sides. So this is going to look like sine inverse of sine A. Well, that's going to equal the sine inverse of 0.87. Sine inverse and sine undo each other, so they cancel each other out. And you're just left with A on your left-hand side. And on the right-hand side, you're just left with sine inverse of 0.87. Can someone tell me what that equals to the nearest tenth of a degree? So we're just plugging in sine inverse of 0.87 in our calculators. Hemsel?
60.45.
To the nearest tenth.
Oh, 60.5.
Yep, 60.5. Yeah, the directions say to the nearest tenth. Notice we flip around a lot on those. And we're going to make sure to put a degree symbol because it is an angle. All right, next one's almost identical, except for this time I'm going to take the cosine inverse of both sides. So I'll do the cosine inverse of our cosine of B. And then we do the same thing to the other side, take the cosine inverse of the right side. And so that's cosine inverse of 0.15. That means our cosine inverse and our cosine will once again undo each other, and so we're just left with the B. It's kind of like if I do 3x divided by 3, you're just left with x. Same idea. Or x squared, if you take the square root of it, you're just left with x. The same principle is happening here. That's going to equal cosine inverse of 0.15, which you should get about 81.4 degrees. All right, the last two are just kind of like exit tickets. Work on them. And as soon as you get the answer, raise your hand and I'll check it off, and then you can do your homework.